Hello everyone. So today I will be teaching you probability and distributions, and this is the week 4. So there are some outline what I will be teaching you. So last class I have covered the random variables, discrete random variables, and all those things. So this particular class we will see the problems related to the week 4 and what can we see using MATLAB, because this is the course regarding simulation of communication system using MATLAB. So these things we have already covered. Due to power cut, I couldn't check on this. So sorry for that. But yeah, I will be continuing from wherever I left. So these are the probability distributions. I told you that why the binomial distribution and how it looks like, what is the expectation and the variance of it. So moving ahead, the next distribution is a Poisson distribution, and it is also a discrete distribution, but it evaluates the probability of usually the small number of occurrences out of many opportunities in a period of time, like the area, volume, and supposed distance. So, but it is what it measures is P of x is equals to lambda power x e power minus lambda by x factorial. So x is here is a random variable. Okay, so this is the mean. Suppose what will be the mean of this, and what will the variance? So means, as we know, that mean will be nothing but so I have to switch on the camera as well. So mean is nothing but using the same formula, x effect, x px. Since this is a discrete one, so that's why we are using summation. So this is a summation of x e power minus lambda lambda power x divided by x factorial. So by solving and all, so we are getting lambda, and later we'll get to know that using binomial distribution, what you have, the mean is NP, right? In that case. So here the lambda is nothing but NP. Whereas the variance in above case was x minus p the whole square was NPQ. And here, here the variance itself is only lambda. So lambda is a parameter which governs the mean as well as the variance. So this type of distribution is Poisson distribution. So if we say the real life example of the Poisson distribution, it is, for example, time of arrival. So if the packets are arriving at particular time interval, the average duration by which the packet is arriving again and again, that average duration is lambda. Okay, I hope this is clear. Now, Poisson distribution example. So in the last meeting, one other guy joined due to some issue. Um, your MG has joined. So if you don't mind, can you please solve this question? Let's see how we can solve. So say in the given stream, there are average 3 strip trot per 100 yards. Okay, this is the question number 2 that I'm covering. What is the probability of seeing 5 strip trot in the next 100 yards? Assuming a Poisson distribution. So it is actually asking 5. Okay, 100. So average is 3 by 100. Okay, lambda is something but 3 by 100. So it is asking 5. So P of x is equals to 5 e power minus lambda, lambda power x by x factorial. But the lambda here, it will be 5 by 100. Let's see the solution itself. So it is showing per 100, you are having 3 power 5 and e power minus 3 divided by 5 factorial. So it is 0.1 per 100 yards. So that's very simple. And like this only we have to solve. Okay. So continuous probability distribution. So we have seen binomial, Bernoulli and Poisson as a discrete distribution. Wherever we next we will see continuous probability distributions. Okay. So a continuous random variable can take any numerical value within some interval. A continuous distribution can be characterized by the probability. It's probability, right? So again, for example, for an interval A to B, P of A x less than equals to B, here we can solve using And last class I told you what is PDF and CDF. So this is PDF. Okay. And the calculation of probability using PDF is not a CDF. What is CDF in this case? CDF will be minus infinity to x, f of x dx. So here the x is there, and from minus infinity it is calculating. So this is CDF. Okay. This function fx is called the probability density function, and every PDF fx satisfies this particular property. Like the area under the PDF, it should be 1, and it should be greater than or equal to 0 for all x. Okay. Now going to the continuous probability distributions again. So there are an infinite number of possible outcomes. So if we define, so instead if we have to find using tables, software, integral calculus. So if a random variable x has a continuous distribution for which the PDF is fx, then expectation e of x and the variance x are defined as this particular thing. In previous case, we had summation, right? And the first example of continuous random variable is uniform distribution. So uniform distribution for a particular interval, it is giving all the values to 1. So this is 1 by t minus c for c less than equals to x less than equals to t. Otherwise, it is 0. Okay. For two values a and b, p of a greater than x greater than b is equals to how it will you have to calculate. How will you calculate this p of it ranging in interval a to b? You have to calculate using the same integration formula. Okay, from a to b minus p of a. So it is like 1 upon t minus c, and like the whole way, and from a to b only it is there from b to a. So from the area of this particular thing is probability from p of a to b. Area is nothing but this one. Okay, length into breadth. Okay, so mean and variance also you can calculate the same formula. Then the mean for uniform distribution is a to b by 2. This is the interval sum of two extreme intervals divided by 2. Okay. Now we will go to normal distribution. This is very often used in wireless communication, digital communication, and we will see also for this. So the probability density function f of x is given by 1 upon sigma root over 1 2 pi e power minus x minus p whole square divided by 2 sigma square. Okay. So now we will see how can we calculate the moment generating function. Give me a second. I will just put the charger for my laptop. So yeah, the moment generating function is defined for e of e power dx. So why this is called moment generating function? Why? Because if you differentiate and keep the value as 0, you will have the moment for that particular value. For example, e of x. So suppose if you differentiate, because this power of 1 only, right? So it is phi of t e of x, that is nothing but v, is nothing but phi of t differentiation at t is equals to 0. Okay, this is e of x. And now if you want e of x square is equals to, then it is v square value, right? E of x square is given by minus infinity to infinity x squared fx dx. It's nothing but phi of t double differentiation, sorry, differentiation, double differentiation at t is equals to 0. Like this. That's why This is mean square value minus mean value full square. That is a variance effects. From the previous example we saw. Okay. Now we will say question number 4. Let's solve this. MG, would you like to take it on? I'll give you 2 seconds to please see and please comment down if you haven't down. Say a toy car goes an average of 3,000 yards between recharges with a standard deviation of 50 yards. Okay. Example that is mu is equals to 3,000 and what was given? Mu is equals to 3,000 and 50. Okay. The standard deviation of, so it is not written here, sigma standard deviation of 50. Okay. So what is probability the car will go more than 3,100 yards without recharging? So it is asked P of X greater than 3,100. 3,100. So you have to calculate 1 minus P of X less than 3,100. So this is nothing but 1 of F of X 3,100. Right? Or else we can directly calculate using 3,100 to infinity. Right? And this is Fx dx. Let us see how these people have calculated. Similar way only they have calculated. We can say if X is greater than 3,100 is equals to P of X, Z greater than 3,100 minus 3,000 divided by 50. Because why you can say like this? Why you can say like this? Because this is equal to P of Z. Z is greater than X minus mu divided by sigma. And that is what it makes sense. Because you are converting every distribution to a normal distribution. So that's why it is like this. I hope this is clear. So this is like a distribution where you are keeping the normal distribution as mean and the variance. Now the third type of distribution, which is very common for the continuous random variables, is the exponential distribution. So the probability distribution for the exponential random variable is 1 by theta e power x minus x by theta. Now the question may arise, like why the normal distribution you are not telling as a that is the exponential distribution? Why? But not like this. But the normal distribution itself is a one type of exponential distribution. Okay, because there also we have what is a PDF for normal distribution? F of x is equals to 1 upon sigma 2 pi e power minus x minus mu by sigma x minus mu sigma square by 2 sigma square. Okay, but here you had the power in terms of x square, but here you had a power in terms of minus x. But anyway, that won't affect. But you can say that normal distribution is one of the exponential distribution. So let's go ahead. If you have any doubt, please ping over here. Now, if you have to calculate the mean and variance for normal distribution, you can calculate like this. Let's have to question number 5. So suppose the waiting time to see the nurse. So here we are seeing that every problem that I have taken is showing a different type of distribution. Okay, we have started with the binomial distribution, then we went to Poisson distribution, but we can see that every Distribution has its own application. Okay. Now exponential distribution application. Suppose the waiting time to see the nurse of the nurse at the student health center is distributed exponentially. Here it is written also, it is distributed exponentially. Okay. Uh, Now what it is written, what are the things that is given? What are the things that it's given? With a mean of 45 minutes. Okay. With a mean of 45 minutes. Then what it is written? What is the probability that a student will wait more than a half an hour to or to get his or her generic bill? So please, what, how to oppose this problem? Give it a try. Think about it. So again, we have to go through the basic formula. Right? That is very simple. What will the answer? Okay, no problem. So we will see how to solve this problem. So as we know, this is nothing but P of x greater than equals to A is e power minus 1 by theta divided by, what was the formula? X by theta, right? So here the theta itself is mean, as we told. Sigma square is theta square. But the mean is given as some value it is given. It is given 45. So theta is nothing but 45. And theta is 45. Okay. So what it is asked, P of x greater than equals to 60 it is asked, right? Because more than an hour. So R 1 hour is equals to 60 minutes. So it is asked like this. So 60 to infinity f of x dx. Okay. Now we know 1 by theta e to the power minus a by theta or x by theta, let's say it's 16 to infinity. Let's solve this. So 1 by theta e power minus x by theta into theta 16 to infinity. Okay. So here we can say this minus theta, okay? Because differentiate it is integration itself, right? So this is minus 160. So e power minus infinity to minus e power minus 60 by theta is nothing but theta. Let's say theta only. We will put the value later. So this is minus 1, 0 minus 60 by theta. So here we are getting e power minus minus cancel. So e power minus 60 by theta. Okay. So here I'm getting e power minus 60 by theta. So here the theta value is nothing but 45. So e power minus 60 by 45 is the answer. So here they have also solved like this, but they have all only given the answer. So here we have to go like this. I hope this is clear. This is very good question. Just we have to go through like this. Okay, now we will see how in MATLAB it will look like. So in MATLAB, you will have the command P is equals to norm CDF. So it will give what it will give will compute the normal CDF at each value in the X using the corresponding parameters in mu and sigma. Sorry, my camera is switched off. So it is given, it will compute what it will compute. it will compute the normal CDF at each point in the values using the corresponding parameters of mu and sigma. So you can see here, this is x, mu, and sigma can be vectors. So x, and sigma. This norm CDF is x, mu, sigma. Okay. So if you solve here, so please solve in a MATLAB, but it will be like this. Okay. And since x can be multidimensional, okay, and mu can be multidimensional because it is a random variable, right? From -1 to 1. And what will be the mu sigma, and this is a normal distribution, okay? Normal distribution. Okay. So here also you can solve using example. So this can be one after question. Now, expected PDF, this X PDF is actually the exponential CDF at each value of the X using the corresponding parameters in mu and the parameters. But the parameters should be positive. Okay. So X you have to feed and mu you have to feed. Because we know that exponential distribution, how it would look like 1 by theta e power minus x by theta. Right? Theta was the only governing pattern. But here in norm CDF, we will have the two patterns. Mu and sigma, both were required, right? But how normal distribution looks like, standard normal distribution looks like, this is 1 by x, 1 upon 2 e power minus x minus root over 2 by x, x by square by 2. This is normal distribution. I'll check. Give me a second. Yeah. So sigma will 1. So it is x minus x square by 2. Okay. Now we have come to the topic of joint probability distribution. So how would joint probability distribution will look like? So in general, if x and y are two random variables, the probability distribution that defines their simultaneous behavior is actually the joint probability distribution. For example, if x, the length of one dimension of an injection model part, or y can be the another dimension, we might be interested in these particular things, right? We want x also, or I want y also. So they are occurring at the same time. Okay, simultaneously. So the behavior is simultaneous. In that case, it is joint probability distribution. So in discrete also we can have, but the one thing that is common for all, that the area under discrete and continuous random variable is 1, is always 1. Okay. So the joint probability distribution of two discrete random variables can be written as f of x, y, x, comma, y, where PR of x is equals to x, y of y. The joint probability function satisfies f of x, y greater than or equal to 0 and summation of x and y, f of x, x, y, x, y is equals to 1. That's what it's showing. So if it is asked, how will you calculate? If it is discrete, you can directly calculate using sum. So if it is x greater than or equal to 2, y greater than or equal to 2, is equals to p of x equals to 3, y of 2, because here it can be x is greater than or equal to 2. So this can be 1 or 2. So if it is 1 or 2, okay. So it is greater than or equal to 2. So it is 2 or 3. Okay. Where y is greater than or equal to 2, it can be 2 or 3. So all possible values that is coming, we can add. We can add. Here there is no value, but here it is two values. So 0.3 plus 0.2 is 0.5. Similarly, p of x equals to 3. So x is equals to 3 is nothing but all the sum. Yeah, all the sum. Now, if it is asked for the continuous distribution, sometimes it's very easy to see for discrete, but it is very difficult to realize for the continuous. Okay. A joint probability density function for the continuous random variable x and y denotes as f of xy with that satisfies the following properties. F of xy is greater than or equal to 0 again, and the area under both the integration should be equal to 1. And also, for any dimension, if it is belongs to particular region, the area for particular that region is f of xy dx dy. Okay. Now, continuous joint distributions, example 7. So, if we calculate probabilities from a joint PDF, so f of xy, xy c x square y, if it is like this, how will you calculate PR of x greater than or equals to y? How will you calculate? So again, what does this mean? PR of x greater than or equals to y is actually means yes, PR of x minus y equal to greater than or equals to 0, isn't it? Now, if you plot x minus y, okay, so let's say x minus y is equal to 0. Let's we have to plot. So x minus y. So x equals to 0, y equals to 0. So again, this is a point. This is a point. If x equals to 1, y equals to also 1, this is a point. Two, like this. Okay, because this is actually x equals to y. And if it is greater than or equal to 0, it's minus y. So again, it will be the this particular line. Agree? But again, if we plot x square y, so it will be x square y. Okay, I think it should be like this. Something, some curve will be there. But again, we want x square equals to y. So yeah, something like this. But what we want the area common to this. So we have to do the strip integration. My point is like this. So we have to start for particular x interval, similarly particular y interval. So if even if we start with fx y dy, because this was the formula, if it is belong to any region, okay. So again, the integration over that region we have to calculate. Similarly, they have also calculated integration over that region. But the reason we have to calculate very carefully, because if y is going from -1 to 1, why you have calculated like this? Because because x square equals to, let's say like this, okay? So y is equals to x square. Okay. So y is equals to x square, it is less than equals to, okay? So it is going from x square to 1. Again, so I am calculating the y interval first. So y is equals to x square to 1. Okay, x square to 1. Now, since x equals to y, so it is, since this is the interval for y, x square to 1. Okay, but now we know that x square is the lower limit. Lower limit. Now x is less than equals to root over y. Right? For the lower limit. This is a root over y. Okay. And x is y is less than equals to 1. So x is less than equals to root over maximum value y. So this is going from x is from -1 to 1. I hope this is clear. So that's why it is going from -1 to 1. And this is coming like this. And so the value x greater than equals to y is nothing but 0 to 1, because here we have to calculate only this value, 0 to 1, x square to x, and this is the x. I hope this is clear. We will move forward with next questions uh, related to solutions and the week 4 assignment questions, which is very important to discuss. So I'm sharing my screen. Give me a second. My PPT is loading. So these things we have already discussed. We have already discussed these things. So now from here we will discuss, like for every value x, the value of fx is found by summing f of xy, xy, over all possible values of y for small y for capital Y. Okay. So the marginal distribution, how will you calculate? So if you have the joint distribution, you can calculate the marginal distribution over the integration by integrating over particular values. For example, of f, this particular thing is there, this f of x is equals to actually p of x is equals to x. Okay, which you can sum it over capital Y. Okay, you want x, so you have to sum it over capital Y. Then you can calculate the f of x. Okay. Similarly, if you want to calculate for the marginal distribution for y only, then you have to sum it over small of x. Okay, where R denotes the set of all possible points in the range of x, y, for which capital X equals to x, and Ry denotes the all possible points in the range of x, y, where capital Y is equals to y. I hope this is clear, and this is we are talking in terms of discrete distribution. Okay. Now, if you want to compute f of x of 1, 2, 3, and for example, in example 6 that we have discussed, but again, in case of the continuous random variable, how will you compute? So again, here the value will be similar because we have to calculate the individual values. Okay, the value is similar. So similarly, f of y of 1 is equals to p of x equals to 1, y is equals to 1, or plus p of x equals to 3, y is equals to 1, like that. And f of y is equals to a 3, where p of x equals to 3, y is equals to 3. Okay. So marginal probability distribution, which is very common in case of countries also. So again, here in case of summation, you will have the integration. Now, if you want to compute here, so again, we have to integrate, okay? So as we have, what was the function? X square, y. We have to find out this c value. So how would we found the c value? The integration over one particular interval is always 1. Okay, then we computed C value. Then we kept the C value here. And again, f of x equals to integration over dy, and f of y is equals to integration over x. So again, I can calculate like this. Now, independence of the events I have already covered in the previous class, but I haven't covered in perspective of how it will look like for continuous random variable distribution. Okay, so if we have p of x equals to, when x belongs to a and y belongs to b, so this is nothing but simple multiplication of this one. Okay, so this is nothing but p of a in intersection b. So it is nothing but p of a into p of b. But what if a and b are mutually exclusive? What if a and b are mutually exclusive? So I told you that time, what will the value? Mg, what will the value? It is only 0. Because P of A intersection P is not defined. Okay, so independence is covered here. So I think I have already covered 7 questions. So this is the 8th question. So let the random variables x and y denote the lengths of 2 dimensions of a masked part. So suppose 2 dimension is there, and assuming that x and y are independent random variables, and the distribution of x is normal with respect to mean, and the variance is this one. So we have to determine for this particular time. So do you think we have to calculate simultaneously? No, right? Because both two events are independent. Got it? So you have to calculate independently and you have to just multiply. Very good. So when when we are interested in the joint distribution of two random variables, so it is actually useful to have a summary of how much the two random variables depend on each other. And that particular thing is the covariance of the correlation. That are the attempts to measure that dependence. Okay, these are the items that measure the that dependence. So, this covariance is actually defined as covariance of x and y is equals to E of x minus mu. Mu is nothing but E of x. Okay, multiplication with y minus E of mu of y. Okay, so which is nothing but E of xy minus E of x y. So, can you think like, do you think if we have independent random variables, so what will be the E of E inside x, y? What will that? And what will the covariance for that? So answer is covariance is 0 if x and y are independent, because there is no variance in that. And that's why E of x, y is equals to E of x multiplication with x of y, E of y. So that's what the covariance and the correlations are actually the items to measure the dependence. It is not defined for independence. Okay, so there are some properties, and also the correlation coefficient is also there. That is nothing but the covariance of xy divided by sigma of x divided by multiplication with sigma of y. Okay, sigma of x multiplication with sigma of y. And also the covariance with itself is a variance, and the covariance of x of y is equals to covariance of y into x, and that will not be affecting each other. And if we sum with some value with a and b, because e of x and y, e of x plus a is what? It will be a plus e of x, right? So do you think that it will affect the covariance? No, because you're only summing it with some value. Okay. So correlation coefficient is very important. It is often used in the machine learning. Okay. It is often used in the machine learning. So till now, if you have any doubt, please ask. But again, if we are multiplying with some value, then the value is going out. So you can see covariance of A, X, and BX, BY is equals to AB covariance of XY. Okay. So, slide. So if we see, have some example. So if we have mu of X, mu of Y, you can calculate. I'm not going into it. Covariance and correlation example is there. So let's solve this question. So give us a minute, think about it, and how will you solve? So E of xy is equals to nothing but integration of 0 to 4, 0 to 2, xy, f of xy dx of dy. So that we are going to the formula. And since it is defined from 0 to 4 in case of y, and it is defined for 0 to 2 in case of x, that's why the area covered is integration itself. So you can solve the integration you can have. So if you have any doubt in the integration, you can just mail me. Maybe I will cover the integration part in the next class. So this is again calculation with the covariance and the correlation. We can directly solve and see, not a problem. So for your understanding, I'm giving you. So in general, I was telling that if X and Y, but yeah, if X and Y are independent, then their covariance is definitely zero. But if any covariance is zero, then you cannot imply that X and Y are independent. So this is true in one side, one side, it is not true in other side. I hope that is clear. So this is bivariate normal distribution. So what it is showing is if X and Y are independent, then this correlation that is R is zero. The bivariate normal distribution actually the joint distribution of certain linear combination of independent random variables having the standard normal distribution. So it is actually the distribution containing the certain linear combinations of independent random variables. That is the random variable itself is if you say the linear combination. So it is often used in machine learning. So this is very important. So if you have some sort of linear combination means alpha x plus beta y, where alpha and beta are the scalars, where x and y are the normal distribution. That is a standard normal distribution. In that case, that is a bivariate. So bivariate normal distribution is the linear combination of independent random variables having the standard normal distributions. Okay, so you can see how it looks like. The bivariate normal distribution actually arises directly and naturally in many practical forms. Okay, so for example, heights and weights of the individuals in the population will be approximately bivariate normal distribution. Why I'm telling height and weight? Because height and weight are the two normal distribution that we can convert it to standard normal distribution. Okay, and if we have the linear combination of any form, so it will be the bivariate in nature. Okay, so again, this is one of the problem that is example 11. Suppose X and Y are represent the induction model part and have bivariate normal distribution. And then the probability that a part satisfy both specifications is what? How will you calculate? So again, this probability can be obtained is integration. Unfortunately, there is often no closed form solution to probabilities involving a bivariate normal distribution. But in this case, the integration must be done numerically. That you can do, okay? We are going to last slide. This is in the MATLAB. Like how can you see the MATLAB? So this is the MBNCDF that returns the multivariate normal distribution, normal cumulative probability with mean, mu, covariance sigma, evaluated over the rectangle with the lower and the upper limits defined by XL and X mu, respectively. So mu is actually 1 by d vector, and sigma is d by d symmetric positive definite matrices. So one thing to note that sigma is always positive semi-definite matrix that we saw in the last class, last to last class, I guess. So if you have any doubt, still you can watch that. And mu is, if you have mu like this, example, then this particular value, what is the probability? Multivariate normal cumulative probability. Okay, this MN CDO. Suppose you are having some doubts over it, but you can actually discuss all those things in a help command of MATLAB. Okay, so I think I covered sections. So next time sharing, sharing something else. Stop sharing for a while. So I hope you can see the MATLAB. Give me a second, it will just start. I'll show you some demo for the sim. So we will see some array calculations. So I think we have seen all these things. So we will see the function calls. How can we do in the MATLAB? Then we will go to wireless communication also, using this self-paced MATLAB course. This is governed by MATLAB itself, but it takes some time uh, to start. Sorry for the delay. So suppose you have the task of, you can apply the size function to a vector or a matrix to produce a single output variable containing the array size in a two-element row vector form. So if you have the first element, that is the number of rows, and second is the number of columns. So the size is very important to see that. Okay. So we have to see the size is equals to size data. So where the data itself is the data file that is coming from the this particular value, the command window workspace. Okay, I can see the data value also. Let's first run this one. Let's run this. So D size it is showing 7.4. Okay, so let's submit this and let's see whether this task is correct or not. So it is correct. Next, let's go to next task. So you can also request two output variables from the size function. In this case, each variable, the one thing to note is in MATLAB is it always gives output as array. So output of the data itself is array only. Okay. Now if I want to see V1, what the V1 contains, so let's say V1, it's data file. So I want to see this. So V1 is actually this one. What is the data file? I want to see data file also. So data file. So this is not the command window. We can directly see from here. So it is showing not recognized because it is a file. We cannot see like this. So we have to see data itself. So what is data? So data it is given. So that's why V1 is nothing but all the values of third row, third column, where it is all the values for the fourth column. So that's why V1 we can see V1. Now we can see V1, V1. So it is third column. Okay, all the values. And if we want to see V2, so fourth column, all the values. So this is fourth column, all the values. Fourth column. Okay. Now, give me a second. Just have this. Okay. Now, what is this? So it is asking, create a variable dr. So we have completed task 1. Let's go to task 2. Create a variable dr and dc that respectively contain the number of rows of the columns of the variable data. So as I was telling that the output of any MATLAB function is itself giving only an array. Okay, so it is giving the form of rows and columns. So dr and dc. dc is size of data. Let's first run this. So dr is dc. Let's see that. Okay, it's correct only. Now let's go to the next task. So it is showing you can find the maximum value of a vector and its corresponding index value using the max function. So you can see the max is a built up MATLAB function and it is also returning the vector. So that's why. But when we started with MATLAB, so what is vector, what is scalar, and what are the arrays? We have seen that because it is utilized here. Okay. And the first output of the max function is a maximum value of the input vector. Okay. Whereas the second value is index. So what is the task is create the variable Vmax and IVmax where containing the vector value V2. So let's go to the task 3. So Vmax IV max is supposed to max V2. First run this. So it is giving like this, and V2 has the maximum value of 10.15 true at the index of 5 because MATLAB works from 1. Next task. So if we can have further practice, we can go. If you need only second output from the element, so you can have right. That is correct. So if you want only second output, so you can use this tilde sign. Suppose we want to use tilde. Let's see. So tilde. Suppose we want 1. Okay. That's tilde is actually restricting. Yeah. Suppose to, like let's say bit will also work. Correct Vmax. So here it should be V bit. Let's go to the next section. So it is showing something. So if you want to have A, size, random means, it will have the array, matrices from 0 to 1. So we saw how the random works. So we can see uh, using what value using what command we can have the normally distributed random variable. And we saw how it looks like. So just now, this is a practical demonstration. So we have these three descriptions. These all descriptions. If random is only used, so it is giving you the random scalar drawn from the normal distribution that we have 1 upon root over 2 pi sigma square e power n minus x minus mu whole square divided by 2 sigma square. Okay. But if we have random, it is giving the n by n matrices of normally distributed random variables. Similarly, we can have many sizes. Okay. So it will denote the array of random variables where SZ1, SZN indicate the size of each dimension. For example, 3 by 4. Okay. So this is the official but we will now practice something. So the MATLAB documentation contain examples and information that can help you when working your own problems. So if you want to see the documentation for RANDI, okay, so we can see help RANDI. Let's run this. So it is giving all the possible things. If you don't know anything, you can just type this. So the pseudo random integers from the uniform discrete RANDI is giving the maximum returns n by n matrix containing the integer values containing pseudo random integer values drawn from the discrete random variables on I1 to I max. Okay, 0 to I max, it is gold. So this is the normal distribution. Okay. Now what it is asking, create a matrix named X that contains a random uh, integers in the range from 1 to 20 and has 5 rows and 7 columns. So we can have how much, what we want? We want X equals to random. So here we are seeing the distribution use case in MATLAB. So we saw already what is a uniform distribution. This is the random is nothing but a uniform distribution. That then what we saw is a normal distribution. And RAND itself is also a uniform distribution that only generates the values between 0 to 1. But here it is the values. So it is asking 20. So from 1 to I max is 20, whereas 5 and 7 columns. So let's run first. So correct only, right? Let's submit it. So it is correct. Okay. Now you can also open the documentation using doc function. So if you want, if you know the name of the function, if you want more information, you can use a doc. However, if you don't know the name of the function, you can search the documentation using phrases also. So let's first do doc like that. So MATLAB is very good in terms of documentations and everything. See, it is giving every documentation. Did you like the MATLAB? I hope you like. So the basic difference between random is like you have to provide IMAX. Whereas random, you didn't provide the IMAX value. Okay. Now let's go to next question. MG, you are still here. Very good. Now, how can we plot? Okay, plotting is very good. Is very MATLAB while learning MATLAB. So you can plot two vectors of the same length against each other using the plot function. Okay, suppose you have the data file. This is the code given itself, and data and all those things it is given. Okay, so create a plot with samples on the x-axis and mass on the y-axis. So what is this is asking? Plot sample and mass. So let's first run this, how it looks like. Oh, that's great. That's great. Submit. So yes, correct. Let's go to next function. So you can specify the color also, marker of the plot by using different symbols in double quotes, and another input also you can have. Okay. So let's plot. What is the task here? The task is plot sample mass 2. Okay. Double quote it is required with R star. Let's first run this. Whether it is plotting in this. Oh, that's great. It is plotting in this way. Now, submit. Let's go to next task. So hold on also, like we can plot one plot over other. So this asking mass 1, and let's have two plots in one figure. So plot yes. Meanwhile, you please see this. So yes, moving back to the problem. So it is asking hold on. So let's use hold on command. Hold on. Plot samples. Then mass 1. Then black for BIS. Square. So SIS. Let's see. So yeah, black is square. So black is K. Blue is P. So K. Let's submit it. Let's go to the next task. While the hold or state is on, plots continue to appear. Okay, so we have to turn off the default plot behavior so we can have hold off. So let's see, hold off. Because it will continue to plot so many graphs over it. Now, when you plot a single vector by itself, it uses a vector as a y-axis values and set the x-axis data to the range 1 to n. So we can have simple plot p1. So, so this is by default giving through the uniform distribution. Since it is a continuous form, so it's given from 0 to n. Line width also we can have. So this line width, what does this command useful for? When you use the plot function, you can optionally set the properties using one or more name value arguments, which consist of an argument name and an associated value. For example, this command plots a heavy line. Okay, because line width, as we can see, this line width is a by default some values there. So we can have, suppose you want with different value plot, suppose y with the line width of. So y is not given, so v1 is there. So sorry. So like this type of error you can have. Okay. So you can see with different line width is there. Now let's define some value y. Y, let's say you have length space 1 to 5. How many values you want? 8. So let's print first. So length space is giving actually the array of 1 to 5 of consisting of 8 values. Okay. So y is 1 cross 8 consisting of 5 values. So let's say whatever I wanted. One by 8, 5. So let's say what is y? 1 cross 5 consisting of 8 elements. Okay. Now let's plot y as line with equals to 9, 8, something like this. Let's see. Okay, that's great because it is linear. Okay, so that's what I wanted to tell you. This is linear. Okay, and let's have some different functionality also. Red color. Okay, color I have given. So these are the some things. So V1 I have done. So task 6 was nothing but plot. I hope you are getting some point of understanding in MATLAB. I'll cover everything. Don't worry about that. So yeah, your task is plot V1 with red and solid line circle, markers, use the line width of this one. So it is asking plot sample. Since this is x-axis, right? This is V1. This red circle and solid line. Red markers, solid line. Now line that is equals to, let's directly submit it. I think that's what they are asking. So the plot function creates lines. Okay, if you want a different type of plots, so there can be bar or anything. There are other plotting functions. You can see MATLAB plot gallery. So we see there. So here different functions are here. We have these many functions, coordinate, contour, these many functions are there. You can see here. Okay, each plot has different customization options. Okay, creating a histogram of density with histogram function, setting the face color to yellow to I, suppose like that. If you are using a different version other than this, use commas to separate. Okay, name and the value. Next section. So now the task is annotating the plots. How can we annotate the plots? You can add labels. Okay. So annotating the giving the names. Okay. So you can have title. Suppose let's have title. There are two plots already given. So we can have title as sample. Now we can have extra labels to X label and Y label also. So let's say X label. It is asking Y label, right? So Y label is, so yes, X Y label is passed. Correct? Now you create a ligand. So ligand is actually if we have two plots, so you can have, since we have two plots, so let's have ligand as 2 X A, that is experiment A, experiment B, right? Experiment. That's cool. Okay. Now you can use the value of A in different plot rotation. Okay. So let's have this bar. Let's have this. How it looks like. You see, it is showing that bar with data of 3 to 1. Okay. And sample is sample 19. So it is sum is actually giving the value. Sample 19 data. That's great. Some value you can take without any double comma. So let's see this short video first. So basically, we can import the files in our MATLAB. So that's what it is saying. We can import MATLAB, but MATLAB workspace will work for different type of import file. So it will work different for MATLAB, .mat file. It will work different for .jpg file. It will work different for the .text file. So it's what it is showing. So we can import from our browser. So you can see here, this is how it looks like, the imported data. Okay, so that's correct. We can go to the next section. So we can import using load also. Okay. So to extract a variable from the table, you can use dot notation. So suppose this table is there. So elements is there already available in the workspace. Suppose assign the contents of the density to column vector D. So let's D is equals to elements dot city. Okay, so let's note it. That's correct. Now, if you are working with a table, you might want to keep the related data together. Okay. So instead of creating separate variables, you can append the result of a calculation to a table. So like this, we can have, if it is, we can actually calculate and put in the table. So multiply each element of element density with this one and resign with this one. So it is asking elements dot mass equals to, let's quickly do this. We have to dot element wise multiply because it is two vectors are there. Hello all, sorry for the interruption. So again, I'm sharing my screen where we were. So we were here. Okay. So for the quick, I'm doing like this. Supposed to since it is two vectors, so I was telling that dot because it is element-wise vector multiplication. Normal star means that it's a matrix multiplication. So here in this case, it is not valid because both are same. Okay. So it is working. Moving to the next task. So it is telling that you can interact with the table by clicking on it in the output plane of a light strip. For example, you can sort a table or you can have, suppose I want like this. I can sort or I can do the changes. So sort the table from the smallest to the largest, then update the code in the strip before clicking submit. So it is showing short. So okay. It is showing short to smallest to the largest. Smallest to the largest. Smallest to the largest. Whole table I have to sort actually. Let's see this. Did you sort the table correct? So, so let's move ahead. So I don't know. Try extracting the first three ends of the row. We can extract like this. That is correct. So relational operation, logical indexing, all those things we can see in the next class. Still we have some us. So relational operators such as greater than, greater, less than, equal to, and not equal to perform comparison between two values. So the output of any comparison for equality or inequality is either 1 or 0. So let's say whether pi is greater than less than 4 or not. So let's say x. So x is pi less than 4. Correct only. And you can compare an array to a single scalar value using the relational operator. And the result is a logical array of the same size. So let's say test the vector assigned into y value v1 less than 4. So next, you can use a logical array as an array index. So the MATLAB extract the array elements where the corresponding index is 1. So like this, it is very convenient way to do that. Like all the elements of V1 where it is greater than 6, it is showing only that. So create a variable z that contains all the elements where it is less than 4. So z is equals to v1 bracket may v1 less than 4. So you can also use the same logical indexing with two different arrays also. So sample is one array. Okay. So it is showing that wherever keep the sample values for the index, keeping the indexes that where sample v1 is greater than 6. So create a variable a that contains the elements of sample corresponding to v1 less than 4. So again, it is correct. So you can use a logical indexing to reassign the values. So that's correct. If we have some values, we can reassign. So modify v1 so that any value less than is replaced by this. So if v1 equals to what is showing v1 v1 less than 4 is replacing with value of 0. Oh, sorry. So you can combine the logical comparisons by using logical operators and all to find the values less than 6. We can get than 6, like we can have and. So let's see this. We can have. So okay, all the values where this is like this. So it is asking sample where so we can go to next section. That's all. So this is what the flow of your program. So we have come to the flow. So if we can see x equals to rand, and if x is greater than 0.5, y is equals to 3. Okay. So you can simply check using relation operator. These are the relation operator. There we can have the condition. Okay. So what it is asking, modify the script so that the plotting code on lines 5 to 8 only if do plot is 1. So if do plot equal to 1, then n. So correct only, we can see like this. Modify the script so that when the if condition is not satisfied, this line is showing like this. So we can have else. Okay. So, okay. So we have covered this thing. So it is actually showing we have condition one, code else if like this. If we have again a condition and again last is else, and if for every if it is n. So we can have what if when we have two plot or two display both equals to one. So we can have uh or okay, or when only two equals to one, like that. So from here we will see the next class. But literally I enjoyed teaching you. So please join. Thank you, uh, Madhav, for continuing till this point. Okay. And we will meet in the next class. Uh, Thank you so much for joining. But yeah, you can see here we have done so many things, and we will do in the next class as well. I will cover the wireless communication optimization for the digital communication, all those things. So thank you so much.